Ladies and gentlemen, welcome back to my channel, guys. Welcome back to my channel. So I've got a good news for you. How can I say? So this week, from today on Sunday, today's Sunday here until next Sunday, I'm gonna try to indulge, like to explain to you more in detail, like step by step, how you can design three specimen of steel beam. The first one that we have that we're gonna talk about in today's video, we have you have the edge parent steel beam, right? And we have the stiffener. The stiffener is just the plate that we use to reinforce the web. Let me just zoom it for you so you understand what I'm saying. Can zoom it from here. It can be zoomed. Let me do this first. It's lagging. I don't know why. But anyway, so this is our experimental that we did on the steel beam. So in okay, for the purpose of this video, I'm gonna show you how you can use the simulation using Abaqus and how you can compare your result that you got from your experimental and your simulation. It should be almost identical, like almost maybe similar. It can be maybe a bit, but it should be close. No long, not like a huge difference. It should be like close to be identical. You know what I'm saying? So it means that your simulation was a successful simulation. Okay. So as I said, right, so we're gonna have a lot of video. So we're gonna talk about the H beam, and also we're gonna talk about this castellated beam using this stiffener, and also we're gonna combine, of course, the castellated beam together to form a box. So if you don't want to miss this opportunity, just make sure to join the community, guys, by sharing this video, by liking this video, and also the most important part, guys, to subscribe, guys. I don't know how long it's gonna take to subscribe, but I think it's less than 5 seconds. Can you try? Can you count it for me? Guys, I need you to subscribe. I need you guys to subscribe to me, to my channel, guys. It's gonna be helpful and it's gonna make me more motivated, right? So let's go, guys. Let's go, guys. So, first of all, what I want to know first, like before I start designing, I need to know the dimension. So all of the dimension from the experimental and from simulation, they should be identical. It should be the same. Otherwise, we're gonna have some error, or we're gonna have some different results at the end, right? The graph of stress gonna be maybe a little bit different. The moments, because the moments is about also the length, right? You know, the moment is the length, the force over the length, right? Like the length is involved, right? So let's just see how it's gonna be. So let's just start our video. Too much talking me. All right, so let's start. I will do this first. Let me edit the video. Let's do this. Let's see if there's a way I can explain to you properly without getting lost. All right, so this is how. Let me just show you first what I wanted. What I want. I want. Okay, I want this. This is our supports. We have the first supports here, and we have the other supports here, right? And we have our stiffener. We have one stiffener here. This is the first stiffener. This is the second stiffener. This is the third, and this is the fourth, right? And what I want to do, what I want to know before I start, right? First of all, the most important part is the overall length of our beam. And we know that for my experimental is 2930, right? 30, sorry, millimeter. Okay. Okay. This one, the thing in the middle, right? For people who don't know how to distinguish this beam, the place in the middle, like this place is called web. Okay, don't forget it's a web, right? And I need to know the thickness of the web. So the height, first of all, the height means from this area to this area. How much height does this web have, right? So for the height, for the experimental, let me just check. I don't wanna make a wrong guessing. Let me see. Okay, for the thickness first, the thickness of this, yeah, we're gonna take 6 millimeter, 6 millimeter. Okay. For the height from here to here, from the top to here, like from this flat. Okay, this one's here. These parts also called these two parts, the one that I'm touching, it's called flange. Okay, don't forget, it's called flange. Okay, so I don't want you guys to get lost. So these two parts are called flange. Okay, so from this flange to this flange, so is the height of the web. It's 100 millimeter. I mean 100 millimeter, right? But in reality, okay, but just remember it's 100 millimeter, right? But in reality, this height is gonna change because of the thickness of the flange. The thickness of the flange, let's say thick F. I mean TF means the thickness of the flange. For all of the flange have the same thickness. So the thickness of the flange, it's 8. Is 8, right? It's 8. So it means that the height, okay, in reality, no, in simulation. In simulation, we're gonna take 100 millimeter, right? But when you're designing, right, you have to know the height between these. The height of the web is 100 minus 8, right? Minus 8. So minus 16. I mean, 100 minus 16, right? Is 70. What is 1684, right? 84. All right, it's gonna be 84, right? So it's gonna be 84 from here to here. It's gonna be 84. Okay. All right. Okay, so this is the height, and we also need to know the spacing between all of these stiffen. I mean, stiffener. This distance here, this distance, and here this distance. So we'll talk about this one later. Don't worry. All right. So just to remember this dimension, but we don't need to remember. I'm gonna explain to you later. I'm gonna give to you later, right? But you have to understand why I'm taking this number, right? It's so important. And what do you want to know? And here, okay, I'm going to talk about it when I start designing the stiffener, so don't get lost. Okay, let's just start in Abaqus. So I've started like since before, but I can start off again. I can just restart, right? Okay. So okay, I'm gonna restart. So I'm gonna go on model. I'm gonna go on this model here. I'm gonna right click on this, and then I will click on create. I'm gonna create the model. So this is gonna be our third model. I'm gonna create the model. I'm gonna say let's say YouTube YouTube H parent, but it's kind of long though. It's parent beam, okay. The description, we don't need any description. We don't need any other things to be checked. You just click on OK, right? So now we have our three model. The first model is this is the thesis that I was doing before, the model one, and this. So our model is YouTube H parent beam. Don't forget about it, okay? And you can, if you save it, I'm gonna press to save the model. And if it's not saved yet, the computer will tell you to save your model at the end of your design. I mean, during your design, the computer will remind you to save your model. I will remind you that how to do it. So don't get lost. Okay. All right. So here I'm gonna open my model, and the first thing that I'm gonna do, I'm gonna search for party. So if I go on the module, I'll change all of the module to parts. I'm gonna click on part. Okay. And then for this icon here, create parts, I'm gonna click on create parts. So create part is to create parts means to sketch your model, right? I know my model should be at edge beam, right? So and it should be, because I'm doing the reality, so I'm gonna take 3D deformable and shelled. Mine should be shelled, and it should be extrusion, okay? And the approximate for the size, sorry guys, for the size of the drawing, because my beam, I said my beam is, I didn't give this, okay, I say it's 2930, right? 2930. The length is 2930. The height is 1000, right? So I can just say, let me just take 2930. Let me just take, I'm gonna take the double. This is not, this is just for the resizing your sketch, right? Like this doesn't, it doesn't affect anything. It just affects the frame of your drawing. Okay, so don't get confused here. So I'm gonna just take 40,000 because my drawing is 2930, so it can fit inside. Okay, so I'm gonna just click on continue. Then here I've made more option here. The computer is a little bit I don't know, can I say it's a little bit slow. So I need to specify which the original what is the original point for me to start drawing. So I'm gonna use this option here to create isolated points. I'm gonna click on it, and this should be my point, my original, because you can see X here, right? You can see X and Y. If I click here, it's X and Y equals to 0. So I can just click here, and then I'm gonna go here on add constraints. I'm gonna click on add constraints. Then I need to fix this point to no move. I'm gonna just select it, and I'm gonna click on OK. All right. I'm gonna close this and click on OK here again. Then I'm gonna start sketching my stuff, my design. So first of all, this is the point. The first, I forgot to tell you though, sorry. The first flash, because we have two flash, we have one opposite side and the other opposite side, right? So the first opposite side is all of them are 25, 25 is 50, right? So I'm gonna take 25. What I'm gonna write it is, you can see here everything's on top, X and Y here. So I'm gonna just set from here, and then I need to have one on the right and one on the left. Okay, so I'm gonna go on X. I'll take 100. So it doesn't change. I mean, sorry. In X, I'm gonna take 25, and Y, it shouldn't change, right? Because you can see if I'm going, as long as I'm going on the right, the Y axis, Y coordinate stays 0. So I don't need to change Y. Okay, so it means straight line. Okay, so it's gonna be 25. Then I'm gonna separate X and Y. So I'm gonna just put 0. Means 0 is for Y. Then I'm gonna click on OK. Okay, and I'm gonna press escape. Let me just zoom it a bit. Let me use the pan to navigate. Then here I'm gonna click again here. I'm gonna repeat the same. Should be 25. Now it's negative Y, so I'm gonna take a minus 25, and then Y should be 0, should remain 0, and then I'm gonna click on OK. Okay, don't worry, if you make a mistake about the dimension, I'm gonna show you how to check it, so don't worry. So just subscribe, guys. I need you guys to subscribe. Okay, so I'm gonna click it here. Now is the point for me to design the web. So these are the flash, right? So I need to design the web. So it should be here from the middle, and then it should go down until until how much again? 100, right? 100. Okay, so what I'm gonna do, I'm gonna just write X is equals to 0, and then Y should be, sorry guys, should be 100, and then I'm gonna click on OK. Okay, now I have the height of my web. All right, so now I'm gonna just repeat the same parts for the flash. Escape. I would go here, go here. So should be minus 25 and minus 100. 100. I'm gonna click on OK, and then the other side also should be 25, positive 25, and then negative 100. I'm gonna click on OK. Okay, now I have. Okay, now before you confirm, right, it's better to check your dimension if all of your dimension are correct. So to check it, just go here on your left part, and then go on add dimension. Just click on add dimension, then click on any parameter. Just click here, and then you can see it's 100. the height is 100. For the thickness is later, not now, because I'm using shell. I don't need to specify the thickness right now. I need to specify the thickness in section, not now. Okay, so don't get confused. So I'm gonna press escape to cancel the function. Then I'm gonna check if it's 25 or that 25. I'm gonna remove it. All right, so now it's my time to specify the length of to specify the length of my shell. Okay, so what I'm gonna do, I will go on confirm. Okay, and then here the depth means the depth means that the height, I mean the length uh of the beam, right? And I told you how much again, do you remember? Yeah, 2930. Then I'm gonna click on enter. Now this is how things starts. This is how the spicy thing starts, you guys. So if we get any confusion, if you don't understand anything, you can just text me. You can ask me any kind of question. I'm gonna reply you. Okay. And by the way, if you have your thesis to do, or you have any design that you want me to do for you, any type of design, architecture, and engineering, you can just email me, right? And we can talk about it. All right. So let's just start. Okay, so this is how our beam gonna look like, right? You can see we got the shell. Let me do this. We got the shell. We got the web. We got the flash. I mean these ones and these ones, right? All right. So now we need to define the material, so the properties. I'm gonna go on properties. So the first part is the parts. The second part is the properties, right? So because for our projects, for my experimental, right, all of the flash and the web, they have the same material, all right? They have the same elasticity and the same plasticity, right? But according to your work, it can change. And what I'm gonna show you, I'm gonna just create the material. We'll create the material here, and the material should be steel. Let's say, because the type of material that I'm using, the type of steel that I'm using is I'm gonna use steel, as I said before, but we're using Q. Let me just be more specific. I'm using Q 355 B. All right, 355B. This is the type of steel that I'm using, so it can be a little bit different from you because all of each parameter, each B, I mean each steel has a different type. Okay, so I'm gonna go on general mechanical here, and then I'm gonna take elasticity, and then I'm gonna take elastic. All right. For the elasticity, I need first of all to know the Young modular. For us, we take 20, 21, and 40, and then for the portion ratio, we took, of course, as usual, 0.3, and then I'm gonna confirm. Let me go back. Let me just confirm first. It's okay. It doesn't matter. Let's just go here. I made a mistake a bit. Let me just go here. Material management. Just go here, and then I'm gonna click on still the material that I created before. I'll click on it, and then I'm gonna click on edit. I forget to define the plasticity. Okay, so we already have elasticity. Now I'm gonna go on mechanical, and after mechanical, I'm gonna go on plasticity, and I'm gonna take plastic. For the plastic, we have a metric of number, but it can change according to your work. So for the yield strength means when the steel is breaking, it's reached its ultimate strength, right? It's 530, and the plasticity is 0 at that time. And then I'm gonna press enter because it's a metric metric value. And yeah, when the yield strength reach 560, the plastic strength was 0.01. Okay, and then it's increased at 0.003, by that time the stress was 590, and then the last one, it was 6620. Then the strength was 0.06. Okay, so this is how the material was modified. This is how the plasticity was modified. Okay, before the before material break, this was the observer. This was the material, right? Okay, so I'm gonna click on OK. So now I defined the material already. So now I need to define the thickness of this because we don't know the thickness. Now I didn't indicate any thickness, right? So I'm gonna go here on section. I'm gonna create section, and then section should be shell, and then should be homogeneous. Let's just give a name. Let's say flage. Let's start with flage. Let's start with flage. Okay, the first one should be flage, and then we're gonna continue. It's kind of slow though. Our material is steel structure, and the thickness, as I said, the thickness of the flage. How much was that? 8. Let me see first of all how much we take. The flash thickness was 8. I'm gonna put 8, and the material should be the same material, steel structure, steel Q355B. Then I'm gonna click on OK. Then I'm gonna go again create section because we have 2 different section here, but we're gonna have 3 later on. Later on for when I need to post this stiffener, I need to create another section for those stiffener. So here I'm gonna take web. Web is this one here. But for the web, I will take the same process. The category should be shell and the type should be homogeneous. Then I'm gonna click on continue. Then the thickness of the web. Let me see how much thickness of the web that we use. But I think it should be 6. Yeah, it's 6 millimeter, and the material should be the same material because I say all of them are the same material. Okay, so now we need to indicate which one is web, which one is flash, right? We need to talk to the computer and tell to him or to it which one is flash and which one is web. So we need to combine all of this section there. So I'm gonna go here on assign section, and I will select first of all I'm gonna select the web, and then I'm gonna go on set, or we can just start with the set, it doesn't matter. Let's highlight. No, we don't have yet, so hold on. Let me remove the create set. Let me remove create set because we don't have sets, right? Let me click here, remove sets, and then click OK. Then here I can take the section to be web, and then click on OK. Now you can see the web is changing color. It means that it has been assigned of its own section. Okay. Then I'm gonna repeat the same process for the flash. So what I'm gonna do, I'm gonna just click on flash. I'm gonna press Shift and then click again on the other flash. And if you can access to the other flash, you can just go on rotation on top menu here. We're gonna see rotation. Then click on any part, and then you can rotate. Let me do this first. Let me do this. I can just rotate it from here. Sometimes the rotation is a bit tricky because I was pressing Shift. So let me just do this. Go here and here. I was pressing Shifts. Maybe it's rotate. Before I rotate, I need to go here and then adjust my beam. Then I can rotate the beam from this angle. Only from this angle. Yeah, I can see it from here. It doesn't. I can see it from here. I'm gonna press Escape, Then I'm gonna hold shift again. Don't forget to hold shift. I'm gonna zoom my beam. Then I'm gonna pick these parts. Oh, and if you don't want to make a mistake, you have to make sure the selection option is region or surface. Right. So take region. So the computer will select only the region parts. I'm gonna click on it. And then after clicking on those 4 flags, I can just click on. I can confirm that the flash. Then I'm gonna go in section here. I'll take flash. Okay, and then okay, then I will change the value. I'll change the view from ISO view. I'm gonna click on here. Then this is our assigned beam. Okay. Okay. All right. So I'll close this part for the material. Okay, before we go to the assembly, we have to create the stiffener. All right, so important. We have to create the stiffener. For the stiffener, it's gonna be a little bit tricky because you have to understand how it works. So if you wanna make any mistake, if you wanna run your simulation without any mistake, without any error, you have to make sure, right? Let me zoom for you. You need to make sure that the stiffener that you wanna create should start from this angle. Let me remove this. Should start from, so it should touch this flange and this flange. All right. So you have to make sure the distance of this. So the distance from this flange to this flange, it should be the height of the stiffener. And if you don't know the exact dimension, it's 100, right? As I said before. So if you don't know the dimension, you can check the dimension. You can just go on tool and then query. And then distance, click on the distance here. So it's the same. You can just click the distance from here to here. You can see the distance is 100. Distance is 100. The component 0. The distance is 100. Okay. So it means that the height of the stiffener should be 100. Okay. And then the thickness, not the thickness, but the width of the stiffener. So the stiffener should occupy this area from here to here, like it should be in the middle here, like from here to here. So you have to know, so it should occupy the whole, because the stiffener is a plate which we use to reinforce, like a vertical reinforcement. So it should occupy the whole area of this flange. Okay. So what I'm gonna do here, I'm gonna also check from this point. I'm gonna click on the red point to this point. How much distance we have? We have 25. So it's correct, right? We have 25. So now I can create another part. So I'm gonna close the query. And I'm gonna go again on parts. They're gonna ask me to create the second part. Okay. I'll go here on create part. This should be our second part. Let's create it. Let's say YouTube. Let's just say Stephen. Let's use YouTube. Stiffener. Okay. And then it should be deformation 3D shelled by here. It should be planar. I'm gonna take planar. I'm gonna see. It should be planar. And then the approximate size should be let's see how the height. So the length is the height is 100. Let's just take 200 though. It's okay. Yeah, let's click here. Okay. Now you can start designing. Before you start designing, you have to make sure to indicate the origin point. It should be here, and then as I showed you before, we fix this point to no move. Click on OK again, and then you can start sketching. You can use the rectangle line here, then press in the middle and make a rectangle. It doesn't matter the dimension, but because you can change the dimension, you can modify the dimension. Close this and go on dimension. So this should be the height. This should be the height from here to here. It should be the height of our stiffener, because we need to rotate this stiffener later. So I'm gonna click here, and these parts I'm gonna click anywhere. After clicking twice to this line, once this line, I'm gonna click anywhere here. So second times, and then after that, I'm gonna change the new dimension from 63 to 100, because it should be the height 100, and then it's gonna change. Then I'm gonna repeat the same for this part. This part was 25. I'm gonna click first. I'm gonna select the line. Then I'm gonna click on any part, like any point. Then here I will take 25. I will take 25. Okay, 25. Okay, now we have our stiffener. Then I didn't indicate yet the thickness here. I will indicate later. And here I'll press escape, and then I will confirm our stiffener. This my stiffener is just a plate, right? Just white plates, which can be used to reinforce in the vertical position. Okay, so this is our stiffener. We have to repeat the same process we did for the beam, right? I'm gonna go on properties. It should have the same properties. Like, I don't need to modify anything. But here I need to create another section. I'm gonna go in section. I need to indicate the thickness of this big boss here. So it should be also the same. Let's say stiffener section. Okay, should be the category should be shelled, and the type should be homogeneous. Then after that, I'm gonna click on continue, and then the thickness. What's the thickness of the? I don't know the thickness of. Let me just check first of all. Let me just make sure the thickness. How much thickness we took. I already forget about a lot of numbers. Okay, let's just do